In this example, I've set my mean equal to 2, so mu is equal to 2, and our standard deviation is equal to 0.6. I've set up an x value of 1.5, and I'm going to find the area that falls below and above this value in a normal distribution with a mean of 2 and a standard deviation of 0.6. First, I want to draw the normal distribution. So I need to designate the mean and standard deviation. So I'm going to run these first couple lines of code. Then to draw the normal distribution, I first need the range of values. Well, the range of a normal distribution goes from negative infinity to positive infinity. Again, that's not really going to be possible to see on a graph, so I have decided to just go out 4 standard deviations from the mean in the lower direction and in the positive or upper direction. Now, that will give us enough of an idea of what the distribution looks like because most of the data will fall between at least 3 standard deviations of the mean and definitely between 4 standard deviations of the mean. So this will give us a good idea of what it looks like. Now this line of code will give us the range for our normal distribution. So that's what d norm stands for. It's the density. It'll give us kind of the y value. Then we're going to plot the values. In this example, it's a little bit different than previous examples in that I'm going to denote that the axes not be automatically generated by the plot. Instead, I'm going to have specific axes at the standard deviations away from the mean. So it will be at the mean and then 3 standard deviations away from the mean each. So let's go ahead and draw this distribution so you can see what it looks like. And we have a mean of 2 and 1 standard deviation up from the mean is 2.6, 2 up is 3.2, 3.8 is 3 standard deviations up from the mean, and you can see that that's about the same for the standard deviations below the mean. So this is what the normal distribution looks like. Now if I want to add the area that falls below my x value, I can run this section of code and I can see that it's this section down below 1.5. And if I want to look at the area that falls above that, I can run this section of the code and I can see that it's about that much area. So the reason why we draw the distribution is so when we actually calculate the probabilities, it makes practical sense according to the picture. So if I want to know the area that falls below 1.5 or x in my normal distribution with a mean of 2 and a standard deviation of 1.6, I can then run this line and I get a value of 0.2023284. And that kind of makes sense. That's about 20% of the area. So anything that falls below our mean is going to definitely be below 50%. Now, if I want to know the area that falls above that, it's just going to be the complement, and I'm going to get 0.7976716. Now, that makes sense. That is a larger proportion of the data. Now, if I wanted to find, and I'm going to kind of go off the script here, if I wanted to find the area between a particular value, let's say I wanted to know the area between 3 and 1.5. How would I find that? Well, I want to always use my upper bound first, so p norm, and 3 is going to be my x value. Again, my mean is equal to 2. Now I could just put in mu here, but I'm going to be more specific and just say 2. My standard deviation is 0.6. And I'm going to then subtract off the lower bound. So p norm, this is 1.5. comma, and I have to designate the mean and standard deviation again, 2 and 0.6. Now that's going to be the area between 1.5 and 3 in a normal distribution with a mean of 2 and a standard deviation of 0.6. So if I want to run this section, I can just run it up here and I get an area of 0.2498813. Now if I wanted to, I could try to draw that using R as well. I could also just do it by hand, but we'd have to set up a little bit different code. Okay, so that's how I can find area between two values in a normal distribution. Now, if I want to find a percentile, it's very similar to previous problems. So Q represents quantile, norm is the distribution that I am interested in, so normal distribution. Now I put in 0.9, let's say if I want to find the 90th percentile, and a mean of mu and a standard deviation of sigma. Again, I could just put in 2 and 1.6 here. I don't need to put in mu and sigma. but because I've designated it above, I'm going to use that code now. So run this, and I get a value of 2.768931. So that's about right here on our distribution, and that makes pretty good sense. If I were to come back up here and put in a rounded version of that, so 2.77, and just run this again so I can see the picture, then that is where 2.77 falls. This would be 90% of the data, and this would be 10%. So that's the 90th percentile. So I can use RStudio to do all of the calculations for a normal distribution, and it's just a little bit more accurate than the table, and it's really pretty easy. So this is how we can use the normal distribution in RStudio.